This particular slide's about standards, and it's about the standards of lubrication management. This item here is a part of a spool piece on a steam turbine in Australia. You'll notice just in here that there's a ragged section where the spool that ran inside there, the spool jammed. That lubricant used to control the hydraulics that drove the spool up and down inside the cylinder was as clean as an 18-16-13 ISO count. Now, if this means nothing to you, that's part of the problem. Because that ISO count number is vital to understand if that lubricant is in a condition that is safe to use. Let me explain. 18, 16, 13, it's ISO 4406. In that standard is a table that tells us what these numbers represent in terms of actual particle count. This one here is all particles greater than 4 micrometre in size on the longest length. This one here, greater than 6 micrometres on the longest length. This one here, greater than 14 micrometres. So we now have a way to take a sample of oil and count the particles by size and the distribution of those various sizes in the lubricant. This company, when this problem happened, was an 18-16 particle count. And that count was the OEM's requirements. The manufacturer of the equipment said you must have nothing more than that, and that's what it was. And that count caused that. So this lubricant is too dirty to get high reliability out of this machine, even though the OEM said it's okay. And what we'll find is the OEM's requirements are not good enough for reliability. The OEM's requirements are acceptable, tolerable, sufficient, but not good enough. They aren't in that boundary of precision that provides high reliability. So we have now a way to count our particle count. And literally, they take a sample of oil, they put it through a machine, the machine shines light up there and it counts the black dots. And the black dots eventually come out to an ISO count of that order there. What's important here to know is the number. And the question I'm going to ask is, what standard do we have to achieve here? What's the count we need to achieve to ensure that this problem never happens again? Because at 18, 16, 13, what the OEM recommends, it will happen again and again and again across the whole world. Because that's the nature. Now, once I select that, I will have wear particles in there. And every now and again, those wear particles will jam up somewhere in the spool and another machine goes down. And that's a process choice. Someone chose to have 18, 16, 13. What we're beginning to find now, there is a magic number. This 18, the worst it should be is a 14 value. At 14, 13 and 11, same size lubricant batch, no wear particles in this sample. Now, there will be wear particles in the whole circuit, but very, very low numbers, right down to the hundreds per millimetre. Here we're in the tens of thousands per millimetre. So between 40,000 and 80,000 particles in a millilitre of oil. Millilitre is about 20 drops. So 80,000 particles of this nature in 20 drops of oil. Here in 20 drops of oil we're down to only 160 particles. So this here is, each of these black dots is an opportunity for a failure. So high opportunity of failure here, high risk here at this level. Here, low risk, because there's not much opportunity for failure. Not one, not zero, they're still in there. But because they're so dispersed now across a large amount of oil, the chance that will jam up in here in enough numbers to actually cause this to seize, very unlikely. Whereas here, there's enough numbers to cause it to seize. And eventually, every now and again, the dice roll and come up the wrong number and the machine goes down.